All right, hello everybody, welcome back. Last time on our Clipper compiler in Rust, we finished implementing the first version of our IR generation that I kept calling throughout that last video ER. I don't know why I did that, so sorry for that. And the idea for today is for us to start working on the assembler. And if things go according to plan, at the end of this video, we should have an executable that would be able to execute our program, at least the first program that we have. So if we go back to main, this is the program that we want to run. And when we run this program, we should expect to have the exit code from the operating system to be 2, right? Like we set on the variable and var1. So without further ado, let's get to it. So the first thing that I want to do is to change the output from the IR generator to, instead of just spitting out a vec of instructions, to make it simpler to convert to assembler, I'm going to extract a program here as well. So let's do a pub struct program. And this program is the one that's going to hold the instructions. So it's going to have instructions. And this is going to be a vec of instruction, like that. So here, instead of outputting a vec instruction, we're going to delete these and replace it with program. And here, instead of doing OK instructions, we're going to do OK program instructions, like this. No field statements on self.program. Oh, this is clobbering now the program. So this has to be parser.program. Let's delete it from here. And let's see. We need to import parser, so let's go to line 4. Sorry, to 4 up, self. There we go. Here, same thing. We need to make it parser program. Just like that. And I think we have now solved this problem, but I expect on main, when we do this, we would getting instructions. But now we're going to change this to program. And here we're going to do program.instructions. Yeah, it's private. Let's make sure that we make it public, like that. And yeah, we have no issues anymore. All right. Now what we want to do is start creating our assembler. And let's see. Assembler. It's going to have the IR program. It's going to be IR program. And we need to import this guy. Oh, before we do that, yes, we need to make sure that we're importing the assembler. And just to follow the other implementations, we're going to implement assembler, and we're going to have a new method that takes IR program, and it's going to return our assembler like this. And what we're going to do is self program, and I had a brain fart here, program. Okay. There we go. Now, what we want to do when we call assemble on self, we want to create a program as well. So we're going to also have a program here. And much like we had on the intermediate representation, we're going to have an array of instructions here, a vector of instructions. And we're going to have an enum instruction here as well. And if we bring our instructions for the IR, let's see here, instruction, we have copy and fun call. So here we're going to need a mov. And this mov is going to be from an operator to another operator, like this. And we're also going to have the fun call. No, we're not going to have a fun call. We're going to have just call. This is what we have in assembler. Again, I'm going to start with the x86-64 assembler, and then as a stretch goal, we're going to do ARM assembler for the macOS. So we're going to have a call, and we're going to have a identifier for the call. And then, is that it? Yeah, the call instruction is just that, because we're going to use mov to put the values on the. We're going to use mov to assign the arguments of the call, and then we're going to call the call mnemonic in assembler. And then all we need to do on the assemble is, I don't even think we need the result here. Maybe we do. We'll keep it for now. All we have to do is OK, and then do program self.program .into, because we're going to start implementing a. I need to copilot disable, otherwise it's too easy. Let's do that. Let's implement from IR program for program like this, and then we can do this guy. Right, and then we're going to have to start transforming the instructions from the program into assembly instructions, right? So I think we can do something like let instructions equals, and this is source. Can even make it program, I think. It's going to be program dot instructions dot map, and then we have the instruction here. So we have to do either here, and I think what we can do here is do implement from vec ir instruction. Actually, instead of vec, yeah, let's do vec for vec instruction. So then what we can do here is we have instructions, and we can do instructions dot either dot map. Then here we have the instruction, and I think we can do, yeah, we can do into here as well, and then collect, much like this. Oh, into is not a function. I mean, it is, but map calls it. And let's see. So instructions, we don't need this anymore. Yes, we do. We can do here program instructions is going to be program.instructions.into, like this. Nice, I like this. Now we need to go to, so we now need to implement this for a single instruction. From IR instruction for instruction. Oh, and I think one instruction on the IR side can generate more than one instruction on the assembly side. So let's do for vec instruction as well, like this, and then let's implement this. This is going to be instruction, and then this is going to be to do. And this method is going to return a vec of instruction. So I think here what we need to do, I'm thinking, if we do this, it's going to be one-to-one. So I think we need to collect here. Let's think. So we need to collect a vector of vectors. Because then one instruction here, IR, is going to generate more of those, and then we just need to flatten this. Let me see how I can make this work. Let's see. Okay, there's a syntax error, no problem. Let me just break this down so I can see better. iter map and then collect. So what's the issue here? We're missing one angle bracket. There we go. Let me just do this. Okay, and that's actually working, but shouldn't this give an error because it's trying to return vec of vec instead of a vec? Let's see. I think there's something still wrong. Cargo check. Interesting, it's accepting this. Okay. Let's keep like this for now, and let's handle the translation for the instructions then. So we do match instruction. Then if we have, yeah, now I will need the instructions again, but we can zoom here and let me open up IR again. There we go. So let's do this and do this. All right, so copy, it's gonna be source and destination, right? And source is a value and destination is a value as well. So here we have to generate a MOV. So it's gonna be instruction MOV DST into, sorry, yeah, so no, that's right. It's gonna be source into and destination into, like this, I think. And then for the function call, we're gonna keep a to do here. And let me actually create a test. So we can see how we're progressing through this without having to run the code from scratch. So use super asterisk test. And we're going to test copy to MOV. Let instruction equals copy IR instruction copy, and then we're going to have IR vol constant 2 into IR vol, and then what are the var, and then we had, like, let's call it TMP1, or to make a clipper, like we're going to do nvar like this. And then what do we expect to get when we have a MOV? So it's going to be MOV assert equals inst, and it's going to be instruction, so our instruction, MOV. It's going to be operator, constant. Yeah, in assembler, if I remember correctly, we have an immediate value. So it's going to be IMM of 2. And then it's going to be operator, variable, and var. Like this, I think. I'm thinking here. I think we don't use variables here. Let me try to remember what we transformed the var into. Let's go here into instruction. And it's weird that I'm not getting errors here because we don't even have operator. So let me save this. Let's wait. So let's do enum. Let's do here enum operator. Then we have the immediate value that for now is just a I32. And then, oh, I remember. So the idea is for us to have a pseudo register. And yes, and this is going to be identifier. And we're going to have a pass where we go through all the pseudo identifiers and we replace them with a place in the stack. So yeah, this is going to be a pseudo lsp restart. I'm pretty sure we're missing some errors here. That's super odd. Cargo check. Let's see if we go to our assembler. There we go. Now we're getting errors. Okay, so we're going to, if we're going to call in 2, we have to consume self, which I don't mind. Yeah, and we don't have identifier because our identifier is on the IR So if we go to identifier, what I want to do is extract this from here. And we're gonna put it on main for now. This way we can use it from all the places. So let's import it in IR like that. And let's go into our assembler and check out the errors. So we don't have identifier. Now we do. Yeah, so the vec of vec now is giving me issues. That's right. Can I use flatten here? I wonder. Let me check. So docs rs flatten. Flatten. Not what I wanted. Okay, iterative flattens one level of nesting in an iterator of things that can be turned into iterators. So I think this should work. So let's see if we do here flatten, and then we make this something like this. Oops. We're gonna need to specify, yeah, because it doesn't know that I want to extract this into a vec. Like this. Should this work? What is the issue? Yeah, here we still have vec of vec. Mismatch types. Why? Let's do a cargo check here. Here. Expected vec assembler instructions. Expected that. You found vec vec. I am confused. Let's break this down. So if I map it with just into, what does it give me? Let's see. No, I want to do a to-do because I want to see what value this has. So we cannot do into because it's missing the generic argument. So instructions. This is a vector of instructions. So this is going to be, into, hold on. Yes, into a vec like this, right? If we do this, what do we have here? No, we have an error. Let me check this again. This is another error here. The trait from, we need maybe into iter. Let's see. Okay, and like that. And now we would need then if we do vec of vec, would this work? I think it does. Yep. So we can create a vec of vec. Okay. So now what happens if we do a flat map here? And can we do just a vec here? Is my question. Maybe if we spell things right. Ooh. Yep. This is exactly what I wanted. Cool. So we got there. Perfect. Vec is not defined in the current crate. Oh, that's right. I cannot implement from. That's unfortunate, but not the end of the world. So let's do it like this. We can do a free function here. That's gonna be from IR instructions, and we're gonna return a vec of instructions like that. Okay, so we can no longer do into. Too bad, but we can do from IR instructions like this. Okay, you might be missing, let's see. What's the problem here? Wait. Cannot find type instruction. Oh, where did I put instructions here? Assembler instruction is defined in module create assembler of the current crate. So we fixed that error. Let's see what else. Expected a vec. Oh, that's right. So here, since we're returning only one instruction, we need to put that on a vector, like so. Oh, and now it's complaining that we don't have a from. Yep. Can we implement it? No, we need to do it manually. So let's do implement from. And is Copilot still go? Oh, because I restarted. Copilot stop. Copilot disable. There we go. So from IR vol for operator, we're going to do implement the missing member from value. Let's call it val. And then match vol like this. We can do. And so if the constant here is going to be a value, we're going to make it a operator pseudo, and not pseudo, here is immediate vol. And then if this is a variable, we have a name identifier for the variable, then we do operator pseudo name like this, and I think we're good now. Let me just make operator public. Probably gonna need it at some point. You know what? I don't think we're gonna need it. Let's keep it private for now. Okay. All right. So what else we need to fix? Yeah, our little test that we were writing. So this is gonna be a var of identifier like this. What's the issue? Expected string found stir. Don't we support both? We do, but we need to do into. Yeah. We don't need to put the identifier here. We just need to call into, and we're good. There we are. Okay, so now instruction doesn't implement debug. Let's fix that. So instruction. Here we're gonna need derive, debug, and clone and partial EQ if we want to compare instruction like we are doing on our test. And then, of course, operator doesn't implement it. Okay, let's see what else we have. Mismatch types, assembler, instruct. Oh, expect, yeah. Pseudo also takes an identifier. So let's just add an into here. And what's the issue now? Assembler instruction and IR instruction have similar names, but they are actually distinct types. Okay, so what we are getting here is an instruction, and what we're getting here is also instruction. Yeah, so this is, we didn't make any conversion, right? So we need to call into, I think, instruction. Oh, and that's not where we put it, or is it? Let's try it like this. Let inst instruction equals inst dot into. Would this work? The bound assembler, that's right, because we generate more than one. So hold on. Yes, the origin instruction is going to generate a vector of instructions. So we need to call it like this maybe. There we go. And then we do instructions 0. And let's see if we have a test that works. It's executing. There we go. So this passes. And just to make sure and make this a little more clear, let me zoom in, and we're going to do cargo test. And you can see that copy to MOV works. Great. So let's go. So now we need to figure out how to do the function call. And this is going to be a little more tricky, but if I remember what I learned from the writing a compiler book, I'll see if I can make this work. So to call functions, we have to put the arguments of the function into some registers, right? So I think we have up to 6 registers that we can use, but I don't remember them. 1 second. x86 function call registers arguments registers. Let's see. What are the registers that hold function call arguments in x86-64? RDI, RSI, RDX, RCX. Okay, perfect. So, and before doing that, what we need to do actually is creating the registers. So let's go here. Let's do derive, debug, clone, partial EQ, and let's do an enum registers. And we're gonna have the generic names for those. So it's gonna be DI, SI, and so on. Because RSI is the 64-bit version. There are also 32-bit, 16 bits, and 8-bit registers, high and low for the top 8 bits and the bottom 8 bits, but we're going to use the generic name. So DI, SI, DX, CX, R8, and R9. So going back up here where we were doing our function call, yeah, here. We have to declare, so arg registers. This is going to be an array of 6 registers, and we're going to have them in order. So reg di, let me just see here, copy them. And then we're going to do this, then just join them all like this. All right, so we have, this is the order that we need to use them to call. And then if we have more, we need to move them to the stack. So let's do here first. Instructions is that we're going to return is going to be a new vector. Let's return that in the end. Instructions like this. And then now before putting the values into the records, we need to translate the arguments because I think they are values. Yeah, so they are. We need to translate them into operands. So we're going to do that args dot iter map operand from, and we're going to collect them like this. And if I save this, oh, I called them operator. I meant operand. I'm sorry. There we go. So now let's see here. Yep, we don't have a way to do that. Yeah, we do. Here it is. Convert. Oh, yeah. We also need to do into iter here. Okay, and this is a vector. And then let's see. Okay, cool. Now we need to get the first 6 arguments and transform and put them into registers. Let's do a little test here on how we're going to handle that. So let's say that we have args. It's going to be val var 1. How many do we have? 3. So if I do this, yank, paste, join. Okay. It's okay. We can make them operands. Operand. And then pseudo. So let's make them immediate. Like this, then we can get rid of this and this. I think that's fine for now. And then let reg args equals args dot split at 6. What do we have? Cargo test split. No capture. Okay, so we have 6 and 0. What happens if we have like 3? Yeah, so what I think we need to do is, yeah, if it's less than 6, yeah, we have to get, yeah, let's try that. So if we go back here, so if args.len less than equals 6, we're gonna return args.clone and an empty slice like this. Otherwise, we're gonna do args.split at 6. And then we have the register args and the stack args like this. Would that work? Cargo check. Oh, I think that's because we need to transform this into a slice like this, and the same for this. Is that how we do this? I think so. Okay, cool. So now for the register args, register args, we're gonna do instructions push instruction mov, and then we're gonna move the value, so it's gonna be vol dot into the register, so it's gonna be operand. Oh no, we already have a register in the arg registers array. So like this, we need to close here. This is an iterator with items of type. Okay, is there an issue? Expected assembler operand. What is val? Unknown. Yeah, this should be an operand. Iterator enumerate. Okay, we can do into iter, no problem. Still doesn't work. Yeah, so that's fine. Let's do clone. And same here. Expected, oh yeah. So operand rag of this guy. So we need one rag operand here and clone. So after we do this, we need to actually call the function. So it's going to be instructions push instruction call, and then the name dot 0. Yeah, we can make it an identifier. And then finally, what we need to do is to move the result of the call into our destination. Yes, so instructions dot push, it's going to be instruction mov, because the function call, when you call it on x86-64, the result is going to be on the RAX register. So we need to move operand register AX into the destination. We don't have the AX record register. There we go. Instruction of how we call it. Oh, we call it result. Yeah, so result like that. And of course we need to transform it into cannot borrow as mutable. Of course this needs to be mutable. And I think this is all we need for our function call. So let's go back to our main. And let's see if we can print the program now. Let's see, 20. So this is going to be the assembly. And then we have to do let mute assembler is going to be assembler new program. And then let program equals assembler assemble like this. And we're going to do for instruction in program.instructions println instruction, just like we did for the others. Field instructions of field private. Okay, let's make this public. Partially moved. We need to make this iter like so. Private, yeah, so I should have made this public. So let's go to instruction, public. This guy is also probably private. Let's make it so register, also public. Anything else? Remove this mute. Oh yeah, this doesn't have to be mutable. Okay, I think we're ready to test. Let's see. Cargo run. So let's see, we're moving the immediate value 2 to our pseudo identifier, envar1, and then we're moving the value of that pseudo identifier to the register di, so we can call the function, and this is going to be the first parameter, or the first argument of the call. Then we call the error level function, and then finally we move the result of the call into a variable that was created by our IR generator. Very good. Just wanted to tweak this here and add a print line here. And I'm going to add another one here, like so. So now the problem is that, of course, assembler is not going to know what envar1 is. So we need to transform those pseudo identifiers. And in order to do that, we're going to go to the assembler, and we're going to create a new function here on the assembler. Sorry, on the program, called replace pseudo registers. And this is going to return another version of program with all the pseudo registered replaced. So to do that, we have to iterate through all of our instructions. It's going to be self.instructions .iter .map. And then we're going to match on the instruction. What's wrong here? To do. Let's see. Add braces to. No, I don't want to do that. All right, so let's do this manually. Okay, if this is mov source destination, we have to do the following. Let's just do it like this. Instruction mov. Consider giving instruction a type. Okay. like this. And then here we're going to return a new program with instructions, like so. Okay, now we can add the match arms. We have mov, call, and push. And we're going to add here a function handle operators. Operator. I always call it operator. It's operand. And then we're going to have immutable offset. That's going to start with 0. So we're going to add here offset, immutable I32. And finally, we're going to have a map of variable to offset. It's going to be hash map. No. Like this, and we're going to get, oops. Var offset map. And then var offset map is going to be a mutable hash map of string to I32. And we're going to return a new operand. Then if the operand is a pseudo, then we're going to return the following. So here we're going to check if we have the offset already for that variable. So we're going to do var offset map dot get the name. It's going to be name.0. And if we have it, we're going to return operand stack offset like this. Otherwise, we're going to insert that into the var offset map push, not push, insert name.0 to, we need to calculate the new offset. So offset minus equals 4. And then we add the offset here. And then we return the same thing, operand stack offset. And let's see, we don't have stack I32. What else? Dereferencing, yes, let's dereference offset. Same thing here and here. Oh yeah, if let sum, consider borrowing, sure. We're almost there. Let's see. Can be used on I3, but if you dereference, which I will, no problem. Consider cloning. Yep, makes sense. There we go. So down here, we're missing the angle brackets. Okay, cool. Mismatch type. So what is the issue here? Expected. And we found, okay. Oh, we never returned this? Yeah. We need to do the following. We're going to do instruction, mov, and then handle operand source, handle operand destination. Okay, what's the issue now? Let's see. Oh, yeah. We need to pass in the variables that we created here, which I think I'm going to move them down here. Makes more sense. Like so. So we have to pass in the offset and the var offset map. Same thing here. There we go. Let's see. Yeah, we're not calling pseudo register, so let's see where we do the assemble. Let's do let program equals self.program dot into, and then let program equals self dot replace pseudo registers. Oh, we don't have to. Hold on. Yeah. So let program self dot replace pseudo registers. Program dot sorry, we have to make into to get, yeah, and then let program equals program replace pseudo registers. Let's see. Yeah, I think this is not going to be able to infer that this is a program. And then here we just return program. Oops. Program like this. And with that, I think we are good. Let's see. We got a panic here because we left a to do. Okay, line 58. Oh, of course, we didn't do call. So let's see, call takes an identifier and push also takes an identifier. So what we want to do is if it's another one, we're going to do instruction dot clone like this. Let's see. Okay, I think this makes sense now. Yeah, so we're moving now 2 to the stack -4, which was our variable 1. We're moving that to the I so we can call it. And then we're moving the result of the call into a new variable here. And I think that's all good. All right, now that we have the assembly generated here, we have to do another step that I forgot to add to our drawing here, which is to actually do the code generation. So let me move a few things around here, 1 second. All right, there we go. Now we're going to start working on the code generation. And for the code generation, all we have to do is to get the program and implement display for it. Because in the end, what we want to generate is a string, right? So let's do implement fmt, oops, implement fmt display for program. Let's implement format. And then what we need to do here is to do for instruction in self.instructions, print instruction, not print, write f instruction. I think that's it. And I think we're going to end up needing to put an OK here. Yep, and now we need to implement display for instructions. Let's go to instruction. Let's implement format display for instruction like this. And let's see. So we're going to have to match self. And if it's a mov, what we're going to do is the following. We're going to write, we're going to do a tab, and we're going to do a move L, another tab, and then the source, comma, and the destination. I just realized I didn't put source or destination here. Like that. And I think we need to do it like this. For call takes an identifier. So it's going to be the function name that we're calling. Here we're going to do write f. We're going to do call, and then the function name. Pretty straightforward as well. And finally push. We're going to do push operand. So let's do op. Push L, I think, and then the operand. And then we need to add an OK here. What's the issue here? Closing parens, not on here, that it's here. Ooh, there we go. So now it says that identifier and operand doesn't implement display. So let's go to the main first. Let's go to identifier and let's add another implementation here. FMT display for identifier. This one is going to be very, very simple as well. All we have to do is to write F and self.0. There we go. So let's see here. Now we need to do the same for operand. And new implementation for operand, implement format display for operand. Add this guy, and then we're gonna write. Oh, we have a match here as well. So match, match self. Match arms. So if it's an immediate, it's going to be 32. So it's going to be a value, and we're going to do write f value like so. If it's a pseudo, this one should never happen. So let's make sure. Let's put the name here. Let's do unreachable, and then we can add a message here. Attempt to serialize pseudo name. And then if it's a register, we can write the register like so. And if it's stack, it's an offset. It'll be offset. And this guy, if I remember, is something like this. It's going to be the offset, then RBP, because it's a stack offset. And I think we need to put RBP like this. And now, is it like that or like this? I think it's like that. Okay, so now we have to do the same for register. Let's do here, implement format display for reg. And this one, we're going to do a match self. And then if it's AX, we're going to reg AX. We're going to by default return our EAX. And let's be smart here and fill the matching arms. And we can do it like this, replace, whoops. Like that. And then we can do this. This is going to be, I think, R8D and R9D. There we go. Yeah, let's do, yeah. I think this is, there we go, and we're probably good now, which we are. Okay, let's see. And I just realized I don't need this stuff here. We can return it like that. Okay, so now let's go back to our main and let's print. So now I think we only need to do, this is going to be like program. Yep, so we need to do iterator here, like that. And if we run this now, we have errors. Let me see where. Okay. What about now? Close, close. So we forgot to do right line in all the places here. So we have this. Let's see where we're doing right. Here we have to do, this is fine. No, this is not fine. I think here's the problem, right line. Let's see. What's the issue now? Let's see. Oh, did I undo the change? Not sure. There we go. This is our program here. So we're moving to that stack position, same here, and we're calling error level. That's pretty cool. So the next step is for us to start trying to compile this or link this. All right, since we want to compile this to x86-64, and we are on I'm on a Mac machine here, I'm gonna have to SSH into a machine that I have that is Intel. So let's go to code, and then let's clone github.com, coder sauce, y'all. Oh, but I didn't push, did I? Let's see here. Yes, we want to stage this guy, and this guy. Let's commit as fit, feature, assembly. There we go. Let's push this. Let's go into y'all. Let's open a new debug session. Let's get into Vim, and let's do a cargo run here. So now let's try to get this code here. And now if we try to compile it, you see that we get an error, too many memory references for MOV. And that's because I forgot to add this $sign in front of the 2 here. We're gonna have to go ahead and fix that. Yeah, now it's complaining because it doesn't have a start function, right? So basically what we need to do is, if we're in Mac OS, we have to declare a main function like this. But if we're in Linux, which is the case we are here, we need to declare a main, and we need to make main a global like this. So if we try now, the only error that we're getting is because error level is not found. So let's go back to our program here, to our assembler. Let's find where we had the immediate translation, and instead of val here, we need to have a $sign before. And let's make sure that when we're doing the serialization for our program, we add that to the header. So let's find there. Here it is. So what we're going to do is we're going to write ln with a tab. We're going to do global without the a, main, like this. And I forgot to add f here. And the same way we're going to do write line main, like this. Oh, forgot semicolons here. Let's do the following. Let's go to main, and let's write this to a file. Copilot disable. Even though it was good that he helped me with this. All right, let's save out.s, test.s to keep what we had with the program. And now if we do cargo run, cat test.s, and then if we do gcc test.s, perfect. The only problem that we're having is that we don't have error level. And for that, I think I'm gonna ask ChatGPT, how do I set the exit code in assembler? Yeah, so basically you set RDI to 1, you call the syscall 60, which is exit, and then you do syscall. Let's see if we can do that, just for the sake of the example. So let's open up our source file, test.s. Let's add error level. Oops, this has to be all caps, error level. Then let's do mauve. We are getting that. Yeah, let's ask it differently. Let's say, how can we implement error level here so that it sets the error, the exit code, and finishes the program. Okay, I think I'm gonna follow what he said here. We're gonna do leave. And I'm gonna do ret. And let's git grab this guy and paste it here. Let's see what happens if we try it now. Number of operands mismatch, yeah, because we need to do move 60 to RAX, like this. And this has to be a constant like this. Let's try it again. Number of operands mismatch for mauve. Mauve Q maybe? Which line is that? 3? Oh, stupid. There we go. Let me see. What's the error code? 0. So that's not working. Let me think. Oh, I think this is wrong. This is the stack pointer that we need to do here. A.out, A.out, echo status. There we go. So now we finally can compile that program that we had at the beginning, right? But this is a little bit of cheating because we injected error level. We did a lot of changes to our program. So before I move forward, let me just fix this to be RSP. So if I go to assembler, so we had the mauve. I think this is in replace pseudo registers. Where do we have RBP? There. So let's do RSP. Okay. Let's just commit our changes. Let's see here. We had this. Yes. We fixed the prefix for constant values. And finally, we are writing the result of our program. Okay. Let's commit this. It's going to be a feature. Fix generated assembler. There we go. Now I want to do something that I think is pretty cool. I want to introduce a standard library to our crate, to our compiler. So what I'm going to do is I'm going to transform this crate into our workspace. So we're going to create a core folder, and we're going to move everything that we have here to core. Now we're going to have here a cargo toml. And we're going to remove core target. And we're going to create our standard library. So now let's go here. Let's edit cargo toml. So cargo toml. And let's make this a workspace. Let me just remember how to do that. Cargo workspace, not version 2. It's let me see if I can find it. Resolver 2. This is what I was looking for. Okay, so let me grab the other cargo toml. Let me get this. Right. We just need workspace here. Members are going to be core and standard library, like so. Resolver 2. So we need to add quotes to this guy. Yes, what's the problem? Specifies a dependency section, which is not allowed. Okay, let's take it out. Not a problem. Yeah, now we're missing a cargo tunnel inside standard lib. Let's also fix the one here. Let's delete those guys that we're not going to need for now. And let's change this to y'all core, like that. Let's copy this guy and paste it here. I think we won't need any of those. Y'all standard library. And we're going to add a lib.rs here, where we're going to have our standard library. So our first function that we're going to have in our standard, we need to do this since we're going to export this as a, using the C ABI, and we're going to do pub extern C function error level, and we're going to take the exit code as a U8, I think. Oh, no, is it U8? I think we need to use I32, right? In this case, because yeah, that's what we have. And we're going to do process exit with exit code. That's it. That's our first standard library function. And now I need to remember how to do Rust compile dynamic library linkage. Oh, crate type, yes. Tomo. Is that what I need? No, I think we need, let me think. I think we need a static library. Let's see, cargo build. This has to be like that. Can't find library stat lib, rename file lib, or specify lib path. Oh. We need to put this inside source. So let's do that. Let's check now. Use on declare crate or module process. Set exit code Rust. Oh, it's because we're not importing it. Let's see here, lib. Maybe we need to do use standard process. Let's see. There we go. So if we did this correct inside standard lib, target here, target debug, we're going to find a .a file. There we go. So now we have our, so if we try to, another thing that we need to do, since this is going to export as lowercase, we're going to have to patch our function names to be lowercase. And that's fine because I think that's the way it works in Clipper as well. So if we go to assembler and we check the fun call, where we have the name when we do the call, what we're going to do here is do let name equals identifier name dot 0 dot lowercase to lowercase. Like that. Let's run. Then we get error level. So now let's do the following. Let's do jcc test.s. Let's include target debug, and let's include the library lib y'all. No, it's not lib y'all. So let's see list. Is it lib y'all standard lib maybe? GCC include static library. Minus L. Let's see if we find minus L here. Include .a GCC. Oh, maybe you don't need like this. Use minus L. Is that how you do it? Oh, yeah. So you don't need the lib prefix. It's y'all standard lib. Let's see. And what happens if we try to run it now? A.out. And our status is, look at that. We have a standard library, guys. Isn't that cool? Just to make sure that this is working, let's do a println exit code like this. I don't know if this is going to work. So let's compile. This is just a stretch goal. If it doesn't work, we're going to figure it out for the next time. So let's do cargo build. Let's just check if we have the timestamp for our library. 17. Yeah, I think we're good. So let's do GCC, y'all standard library. Let's do A.out. We have a boundary error. I know why, because we basically, if we want to do the ABI system V, I think it's called, we need to align our stack to 16 bytes and 16 bits or bytes, 16 bytes, and we're not aligned. So println is not going to work, unfortunately, but that's going to be where we pick it off on the next part. So just to recap what we finished today, we were able to finish our assembler, create the process to generate code from the assembly, right? So this is done. And now, now we have so it's not done, actually. We need a few tweaks here. So this is what we're going to start with, as I said, on the next part. So I hope you guys enjoyed this long episode. Let me know in the comments below, and I'll see you on the next one.